keeping our astronauts fit and healthy in space is no easy task. Introducing a brand new way to exercise by MGX Technologies. Muscle atrophy right now is one of the most obvious and extreme effects of the microgravity environment that has the potential to really inhibit any long-term space travel. For instance, the Mars 1 colony participants are said to be unable to return to Earth due to these very effects. A recent UC Davis study showed that even while using the treadmill for 30 minutes daily on the International Space Station, 7% of muscle mass will be lost over a 6-month stay. But more importantly, it took our Canadian hero Chris Hadfield more than 6 months to recover from his stay on the ISS, and this is really our main motivation. Recent studies have clearly shown that combining electrical muscle stimulation with an isotonic contraction inhibits the muscle ring finger 1 mRNA protein, which is normally overexpressed during muscle atrophy. This points to the fact that providing stimulation during a concentric isotonic contraction is an effective way of preventing muscle atrophy. Functional electrical stimulation is a technique currently used in the rehabilitation industry that combines loaded exercise with electrical muscle stimulation. While FES products currently on the market rely on the user to time their movement based on the stimulation provided for rehabilitation purposes, our product actually allows the stimulation to be activated based on the custom movement of the individual user.
The project was defined through 4 objectives. The first is to parse the raw data from the exercise motion. Next is to determine the appropriate stimulation technique through research and consultation. Then this stimulation technique must be implemented so that it adapts to individual exercise routines. And the final objective is to demonstrate the motion tracking and stimulation activation through visual evidence.
We're using a 6 degree of freedom inertial measurement unit that collects 3-axis accelerometer and gyroscopic data. Since the IMU data is inherently extremely noisy, a custom phase peak filter was used in addition to a complementary and common filter.
As recommended to us by our contacts at Toronto General Hospital, our product uses the QuadStar 2 NMES device to generate a controlled, maximum comfortable amplitude, 85 Hz biphasic square wave with a 400 microsecond pulse width and 1/2 duty cycle.
All components are connected together through custom circuitry that interfaces the IMU, inertial measurement unit, electrical stimulation control circuit, user interface and LCD with the microprocessor. Finally, a custom case was designed in-house using Creo CAD modeling software and 3D printed using Replicator 2. Not only does it create an aesthetically pleasing way to integrate all prototype components, but it also adds a measure of safety for stimulation electrodes.
Now let's take a look at the motion data. Here we can see the bicep curl exercise, and here are the corresponding IMU values. This signal is right after our complementary, common, and custom phase peak filter was applied to the motion data. Notice how the NMES is triggered only during a proper isotonic contraction and adapts to the individual's varying speeds.
Preventing muscle atrophy is a very challenging problem that major space agencies like NASA and JAXA are still actively researching today. Because of our engineering background, we have limited experience in the medical field, which calls for a substantial amount of research and consultation to determine appropriate settings. Real-time IMU noise filtering and I2C protocol integration also pose significant challenges.
Now that all our current objectives have been satisfied, we look forward to potentially generating the NMES signal internally and cut production costs by over $500. We are also looking at the ongoing NASA and JAXA hybrid training research study aboard the ISS for improvements that could eliminate the need for exercising devices to provide resistance.
As a special highlight, we have been accepted to present at the 2nd Annual Space Conference in Orlando, Florida this coming June.